let us see Mayer's formula, that is the relationship between the Cp and Cv of an ideal gas. So consider an ideal gas, whose equation of state is given as PV is equal to nRT. So we will consider an ideal gas. So we have PV is equal to nRT. So let us taking the differential of both sides. So if I take it, I will get P dV plus V dP is equal to N R dt. So now applying first law of thermodynamics to the system of ideal gas. So we have dq is equal to du plus dw. This is the mathematical way in which first law is written. For an ideal gas, delta W is P dV, and if the process is isobaric, P is constant. So if P is constant, then I will write dq is n molar Cp dt. For whatever may be the process, delta U will be always equal to N Cv dt, and for an ideal gas, work done is given as P dV. So we have here N Cp dt, N Cv dt plus P dV. Now we will use this equation 1 P dV and we will substitute here. So substituting from here, P dV is equal to nR dt minus V dP. Now you know this process I have assumed to be isobaric, for which P is constant. So P is constant means this term is 0. So this term will vanish because P is constant. So now here from this equation we have N Cp dt is equal to N Cv dt plus nR dt. This term vanishes because P is constant. So here N dt cancel out. So we have Cp is equal to Cv plus R. So we have thus a relation that Cp minus Cv is equal to R, where R is a universal gas constant, and this relationship is called Mayer's formula.